Hello, welcome back. The title of this lesson is called the Distributive Property. This is part 1. So if you remember, a few lessons ago, we talked about the commutative property, which lets you add or multiply two numbers in any order you want. We also talked about in the last lesson the associative property, which means when you add or multiply 3 or more numbers, we can do it in any order we want. In this lesson, we come across a new property that is honestly just as important, maybe even a little more important than the previous two, and that's called the distributive property. I promise you I'm not kidding around when I say that you will be using the distributive property forever. It's very easy to understand, so what we're going to do is tackle it by writing it down. So the distributive property is the following. First, let's write it down. Distributive property. Okay, first of all, I want to ask you, what do you think the word distributive mean? What does distribute mean? When you distribute something, you're standing out and you're giving one person, and let's say you're talking about apples. I distribute one apple to him, and one apple to him, and one apple to her, and one apple to her. I have distributed my apples among all of these different people. So I give them away, or I kind of like spread them out. That's what distribute means. Distributive property in math is something kind of similar. It's whenever I take a number and I kind of distribute it and kind of like have it go inside of a set of parentheses and apply itself to everything inside. I distribute the number outside of a parentheses and have it apply to everything on the inside. I distribute that number to everything inside of a set of parentheses. And remember, we use parentheses in math when we want to group terms together and we want to make sure and do what's in those parentheses first. So let me show you what I mean by that. Distributive property. Let's say we take a multiplication problem like this. Let's say we have 4 times 12. Now you all know what 4 times 12 is from your multiplication tables. You know that 4 times 12 is 48. So we know the answer to this problem. And of course, we can, of course, just use this in problems. We know that 4 times 12 is 48. However, I'm going to rewrite the problem to show you how distributive property works. Let's rewrite it like this. Instead of 4 times 12 is 48, let's rewrite it like this. 4 times, and what I'm going to do is instead of the 12, I'm going to open up a set of parentheses. And of course, it's still equal to 48. I can represent this 12 inside of here in different ways, right? Because 11 plus 1 is 12. Right? And 6 plus 6 is 12. I can do lots of things added together to make 12. 12 can be lots of things added together, right? So I'm going to pick one here, and I'm going to say inside of here, I'm going to write 12 as 6 plus 6. So from this line right here is exactly the same math as what is up above, because I still have 4 times, and I have 12 here, and we know that 6 plus 6 is 12, so that's exactly the same thing. The only thing that looks weird is this parentheses there, because we're not used to seeing parentheses. But if you remember that parentheses, you do what's inside first, then 6 plus 6 is 12, and then 4 times 12 is 48. So all I've done is taken the 12 and I've broken it up. So we know that the answer is 48. But now that we have it as a number multiplied by a parentheses, and on the inside of the parentheses, we have two things. We have 6 plus 6. We have two things joined together by a plus sign. So just like me standing out on the corner and giving an apple to him, and giving apple to him, and giving an apple to him, and giving an apple to him, I've distributed my apples. What I'm going to do is take this 4 and I'm going to distribute the 4 to everything on the inside, because this 4 is applying to the whole parentheses thing. So it can go inside and kind of attack the 6, and then it can also go in and attack the other 6. So what you have here is this 4 gets distributed. It kind of like applies itself to this 6, and then it also applies itself to this. So this 4, you can kind of think of like, it's like dropping bombs. It's like flying inside and bombing the first 6, and then it flies inside and it bombs the other 6. And it has to apply itself to everything in there because it's on the outside of this parenthesis, so it applies to everything inside. So what you do is, because the 4 is here and it applies to the first 6, you still have this multiplication symbol. So what you really have is you have 4 times 6, right? And then you have this plus sign, and then it applies to the other guy with a multiplication as well, 4 times 6, right? And so what you get here is you'll get 4 times 6 is 24, and you have a plus sign. This 4 times 6 is 24, And what is 24 plus 24? If you forget, just come over here to the side here, and let's say 24 plus 24, 4 plus 4 is 8, and 2 plus 2 is 4. And so the answer that we get is 48. So the distributive property basically says, if I have a number out here sitting out in front of a set of parentheses, right? And this inside the parentheses, you have two items joined with a plus or a minus sign. Then the 4 multiplies times the first term, and the 4 also multiplies times the second term. Now they're still added together because of what's inside here, but it's like the 4 attacks this 6 with multiplication, and then the 4 attacks the other 6 with multiplication also. When I do this multiplication, I get 24. When I do this multiplication, I get 24. And when I add them all together, I get 48, right? So that's what distributive property is. Now, when I get to this step right here, when I have the multiplications, when I have multiplication and addition, I always do the multiplication first. So that's why I multiply the 4 times 6, and then I multiply the 4 times 6. So I get 24 plus 24, and that gives you 28. So you can see that when I write it with a number multiplied times a parentheses, and I blow it out like this, I get exactly the same thing as if I never did this at all, and it was just 4 times 12, which is 48. The distributive property lets us do lots of different problems where I have to have a parentheses and a number on the outside, because then I go and multiply into the first term, and I go and multiply into the second term. Let's grab another example, and we're going to do a ton of examples to show you how to handle this. All right, let's say that we have 3 times 8. We know what the answer is to 3 times 8. I know that you know that from multiplication tables. 3 times 8 is 24. So we know the answer is 24. But let's solve it using the distributive property. Let's write it as 3 times 8. But let's write 8 as something else. Let's write 8 as, inside here, 4 plus 4. So if I ask you to solve this using the distributive property, what would you do? Well, you would say, I have a 3 times. This 3 must be then applied and multiplied times the 4, and then it also must be multiplied times this 4. So what I will have then is I will have 3 times 4, and then I have a plus sign here, and then this 3 will be multiplied times the other 4. Now when I have multiplication and I also have addition in the same sentence, in the same number sentence, then I always do the multiplication first, before the addition. That's something that you'll also have to remember. Multiply before you add or subtract. So 3 times 4 is 12. The plus sign is here. 3 times 4 is 12. And what do you get? 12 plus 12. Let's go off to the side. 12 and 12. What do you get? 2 plus 2 is 4. 1 plus 1 is 2. And so the answer is 24. Notice that 3 times 8 is 24. That's exactly the same thing. So if we break this up and then distribute in from the outside, I'm going to get 3 times 4 is 12 from this, and then 3 times this 4 is 12. And then when I add them, because the plus is still here, I have to add the results, I'm going to get 24, which is exactly what I know the answer has to be. We're going to do this a lot of times. Believe me, I know the first time you see it, it doesn't make a ton of sense. Let's say we have 2 times 6, and we want to see what that equals. Well, we know the answer is 12, so we know what the answer is, but let's solve it using distributive property. Let's rewrite this 6 as the following. 3 plus some number in a blank. What has to go in that blank? If the answer is 6 here, and I'm trying to replace it with this, and it's 3 plus something, then what must go here is a 3, because 3 plus 3 is 6. So I know I can write 6 as 3 plus 3, and so then what I will do is I will apply the 2 times this 3, and then the 2 will also multiply by that 3, because we have to multiply by everything on the outside. So what I'll have is 2 times 3, and then I'll have a plus sign, and then 2 times this 3. It multiplies times the first term, and then it multiplies times the second term. Now we have multiplication and addition together, so we're going to multiply first. We always multiply first. 2 times 3 is 6. 2 times 3 is 6, and so the answer you get is 12. Isn't that the same thing that we know we should get? 2 times 6 is 12. So using the distributive property, we get exactly the same answer. Let's take a look at the problem 5 times 9. Now, You know what the answer is from multiplication. You know that 5 times 9 is 45. But let's solve it like this instead. 5 times, let's write 9 as the following. 3 plus some number in a blank. First of all, what number goes in this blank? Well, it's 9 here, and we're trying to replace this. So the only thing that works in this blank is a 6, because 6 plus 3 is 9. That's the number that goes in there. And then because I have 5 multiplied on the outside, we're going to multiply 5 times 3. And then we're going to multiply also 5 times the 6. And so the way we're going to write it is we'll say 5 times 3 applied to this term, distributed to this 3. Then we have a plus sign, and then 5 times 6. So we have multiplication going on, but addition in the middle. We're going to always multiply first. 5 times 3 is 15. 5 times 6 from multiplication tables is 30. Now, if you forget what 15 plus 30 is, just go over here and do 15 and 30 and add. 5 plus nothing is 5, and 3 plus 1 is 4. And so the answer you get is 45. 9 times 5 is 45. So we get exactly the same thing. We break this up and distribute in. We get exactly the same thing. We're doing the problems like this to prove to you that when you distribute into parentheses like that, you're getting exactly the same answer as the original problem statement. So you know what you're doing is right. All right, now that we kind of know what we're doing, we're just going to work along and get a little more practice. What if I say 4 times 7 equals what? Well, we know what the answer is. 4 times 7 is 28, but let's rewrite it as 4 times, and let's write it like this, 4 plus some number in there. Well, we know that we're trying to replace a 7 with this, so 4 plus something is going to give us 7. Let's put a 3 in here because 4 going up 5, 6, 7 means that's going to be exactly equal to 7. Now that we have this set up, the 4 here is going to multiply times this 4, distribute into that 4, and then it's going to multiply into this 3 as well. So what you will have is 4 times 4, and then a plus sign, which is joining them, and then 4 times 3. So you see it's like a little bomb. It goes off and hits that one, then it goes off and hits this one. Now 4 times 4 from multiplication is 16, and 4 times 3 is 12. So now you have 16 plus 12. So we go off to the side. Let's go over here. 16 plus 12. 6 going up 2, 7, 8. And then 1 plus 1 is 2. And so the answer you get is 28. When we do it with distributive property, we get 28, and 7 times 4 is 28. So we know that we got the right answer. All right. So what if we have 3 times 11? Let me ask you, what is the answer? You know what 3 times 11 is. It's 33. So we know the answer is 33, but let's rewrite the problem and use distributive property. 3 times, let's rewrite this 11 as something. Let's rewrite this 11 as 1 plus something. Let's fill in the blank. Well, we're trying to make 11 here. So the only thing that can go in the blank is 10. Right? 1 plus 10. And so I have a multiply by 3 on the outside of a parentheses. I can distribute and multiply the 3 times the 1, and then also distribute and multiply the 3 times 10. It goes in and it bombs the first term and it bombs the second term like that. So then what do I get? What I have is 3 times 1, and then I still have this plus sign joining it, and then 3 times 10. Right? And then I'm going to say 3 times 1 is 3. Plus 3 times 10 is 30. And then I know that you all know that 3 plus 30 is 33. So this is the final answer, and you know that 3 times 11 is 33. So by starting with this, getting 33 as the answer in our mind, breaking this up, distributing it in, we get exactly the same answer, so we know that we have the correct answer. All right, problem number 6. Let's say we have 8 times 9. What is 8 times 9? You should know that 8 times 9 is 72, but let's break it up. Let's write this 9 as, let's write it as 5 plus something, right? What has to go in that blank right there? Well, I'm trying to make 9, so the only way that I can put something in here has to be the number 4, because 5 plus 4 is 9. So now that I have something multiplied on the outside of a parenthesis, this 8 goes and multiplies times the 5, and then it also goes in and multiplies times the 4. So what I have is 8 times 5, multiplying 8 times 5, but then I have a plus sign still here, and then 8 times 4. All right, so for multiplication, 8 times 5 is 40, and 8 times 4 is, for multiplication tables, 32. So now we have to take 40 and add 32. So let's go off to the side, 40 and 32, and let's add them. 2 plus 0 is 2. 4 going up, 5, 6, 7 is 7. So the answer is 72, and that's the answer. And 8 plus 9 is 72, or 8 times 9 is 72, which is exactly what we got when we did the distributive property. All right? Only a couple more problems. What about 12 times 8? So we know what 12 times 8 is. 12 times 8 is 96. 8 times 12 is 96. 12 times 8 is 96, however you want to think about it. But let's rewrite this, and let's rewrite this 8 as something else. Let's rewrite it as 4 plus something. So what has to go in this blank? I'm trying to replace 8 with this, so the only thing that works is a 4 in there. Because 4 times 4, or 4 plus 4 is 8. So that means the 12 gets multiplied in times the 4, and the 12 also gets multiplied times this 4. So what happens is 12 times 4 down here. I still have a plus sign, and then 12 times the other 4. Now, for multiplication tables, 12 times 4 is 48. Then we have 12 times 4 is 48. Now you have to add 48 plus 48, and I know you probably don't remember that, so let's go over here and do 48 and 48. 8, let's go up 8 more. 9, 10, 11, 12, 13, 14, 15, 16. So we get a 6, we carry a 1, 4 plus 4 is 8, plus 1 is 9. So the answer we get is 96. And we know that 12 times 8, or 8 times 12, is 96, exactly what we got for our answer there. So we know we got the right answer. All right, let's say we have 3 times 14. 3 times 14. Let's go ahead and rewrite this as 3 times 10 plus some blank here. Now what has to go in the blank? I'm trying to replace 14 with this, so the only thing that works is a 4. Now in this case, I don't actually know what 3 times 14 is off the top of my head, so this is an example of when I don't know the answer ahead of time. But I know how to break this thing up, so what I will do is then I will say I have a 3 multiplied on the outside, so it gets multiplied times the 10, and it also gets distributed in and multiplied times the 4. So what I have is 3 times 10, and I have a plus sign, 3 times 4. And when I have multiply and addition in the same line, I always multiply first. So 3 times 10 is 30, and then 3 times 4 is 12. So I go down here and I say, well, what is 30 plus 12? 2 plus 0 is 2, and 3 plus 1 is 4. So the answer is 42. So I didn't know the answer ahead of time, but 3 times 14 is 42. And I split it up, split the 14 into 10 plus 4, and distributed the 3 in to show that it's equal to 42. All right, let's do the next problem. I only have 2 more. Let's say we have 5 times 15. This is another example. I don't know off the top of my head what 5 times 15 is, but I can find the answer by breaking this 15 up into, let's just make it 7 plus some blank here. What should we put in the blank? The only thing that works to put in the blank there is an 8, because 8 plus 7 is 15. If you start with 8 and go up, 9, 10, 11, 12, 13, 14, 15, then you know that 7 plus 8 is 15. So then the 5 will get multiplied times the 7, and the 5 will get multiplied times the 8. So what I'll have is 5 times 7 plus 5 times 8. Now, what is 5 times 7? For multiplication tables, it's 35. And 5 times 8, what is that? Multiplication tables is 40. So 35 plus 40, let's go ahead and add those. 35 and 40, let's add them up. 5 plus 0 is 5. And 3 going up, 5 4 going up 5, 6, 7. 3 plus 4 is 7. And so the answer is 75. That's the final answer. And that's an example of a problem I don't know the answer to ahead of time, but I can get the answer by breaking this up into smaller multiplication problems that I can then find the answer. All right? All right, we only have one more problem. All right, only one more problem. Let's say we have 4 times 17. What does that equal to? Well, I don't know what 4 times 17 is because it's too high. It's too large of a number for multiplication tables. So I'll break this 17 up. And in this case, let's break it up to 8 plus some number in the blank. What number goes in the blank? The only number that makes sense in the blank is a 9. Because 9 plus 8 is 17. If it were 10 plus 8, it would be 18. But since 9 plus 8, it's got to be 17. So we know that that works. Then we'll take and multiply the 4 and distribute it in times the 8. And we'll multiply the 4 in and also distribute it times the 9. So what I'll have is 4 times 8 plus 4 times 9. Right? Now what is 4 times 8? 8 times 4, 4 times 8, that's 32. What is 4 times 9, or 9 times 4? That's 36. So to find the answer here, what I really need to do is I need to go over here and say, what is 32 plus 36? 6 going up 7, 8. 3 plus 3 is 6. And so the answer here is 68. 68. So the answer to the original problem, 4 times 17, is 68. And I don't know that, but I can break the 17 up and then distribute the 4 on the outside, multiplying into every term there, and then add the answers together at the end. The distributive property is one that we're going to use a lot. It's actually going to be used quite a bit throughout the rest of all of the math that you learn. And it's basically when you have a number or something outside of a set of parentheses, and on the inside of the parentheses you have at least 2 things that are added or subtracted on the inside. So that guy on the outside that's multiplied can then multiply into the first term. That's called being distributed in. And it can also multiply into the second term. Those answers you get still have to be added together because we have a plus sign inside here. All right? Then we get the answers, and you can see for every one of these cases that the answer you get is exactly what you would get if you just go ahead and multiply the original problem. In this case, 45, 9 times 5, is the same answer that we got by the distributive property. I know it's a little bit weird the first time you learn it, and that's why I did a lot of examples. I'd like you to go back through it and try to work through some of them yourself. And then when you feel like you're understanding what we're doing here, go on to part 2, and we'll get a little bit more practice with the distributive property.